This is the big circuit off the chapter review. And you can see that you got a lot of buttons there, a lot of different resistors. Now the question is, the chapter review question asks specifically, find the information for these two purple resistors. I think it's a good exercise to actually find all of them, but we'll focus on doing this first and then fill in the rest afterwards. So, question number 1. What are you looking at? Start the battery and walk your way around. You hit A. And there's no choices, so A must be part of a series. And then you see that you have a choice, and that choice begins here. Let me go highlighter. And the choice begins right here, and then it terminates right here. So A and B through G, this whole big mess, is part of a series. B through G is a parallel with an upper branch and a lower branch. BCD is a series with B and CD. EFG is a series with EF and G. Those contain a parallel and a parallel. So I hope that wasn't too much to handle there. So what we're going to do is we're going to jump back and forth between screens for a second while we record some data. So back to here, and we've got, let's see here, we got resistor A all the way down here is 3 ohms. Resistor B, I believe, was 3 ohms. Resistor, jump back here. C is 6 and D is 6. C is 6, D is 6. Over here to G. G is 2, E is 4, and F is 12. G is 2, F is 4, and E is 12, or did I mix the two of them up? Hold up. I'm sorry. I flip-flopped those. Oops. Flip-flopped them. So we got the individual resistors in here. And our next thing we have to do is start making combinations. So, you know me, I like to start at the bottom, work my way up. So CD being the first thing, it says 2 in parallel. It's a 6 and a 6 in parallel. And so as you're thinking, okay, it's a parallel, 1 over 6 plus 1 over 6 is going to equal 2 over 6. And then you take the reciprocal, and you're going to end up with 6 over 2, otherwise known as 3 for CD. And then we may as well combine BCD. Now, BCD is a series containing CD, 3, and B, 3. Because it's a series, we would add them up and end up with 6. And then we go to this red branch, how I have it here, EF plus G. So we have to do EF first. EF being a parallel of 4 and 12. And so we would say 1 over 4 plus 1 over 12, which you would then do a common denominator of 3 over 12 plus 1 over 12, which adds up to 4 over 12. And you take the reciprocal of 4 over 12 and get 12 fourths, which comes out to 3 for that one. Now for EFG, you have a series of G and EF. So 3 and 2 adds up to 5. And so we've got all the little bits. Now we have this great big parallel right here between the blue and the red in my little drawing. So we have a 5 and a 6 in parallel with one another. And I'm just going to double check my math. If I add 1 over 5 and 1 over 6, I'm going to add 5 thirtieths and 6 thirtieths. So that gives me 11 over 30, and I got to take the reciprocal of 11 over 30 and say 30 over 11. That gives me a big long decimal, but we'll round it off at 2.72. So that was 30 elevenths because of our common denominator math and our reciprocal. So then we're going to do the equivalent resistance. And with the equivalent resistance, we now have to take all the letters. So A down here at the bottom, 3, lonely 3, and the rest of it, 2.7, is a series. So 3 plus 2.7 is 5.72 is the total resistance of our entire circuit. Now we need to fill in the voltage. I'm going to double check, and I'm pretty sure it's 18, sorry. The total voltage is 18 volts. You'll excuse me for not trying to throw units in and make things difficult. So 18 volts here. Now, as I've been saying all along, use Ohm's law when you have two things. So we're going to find the total current. I equals V over R. So what is 18 divided by 5.72? It comes out to 3.14 with lots of data. I'm going to round up to 3.15. 3.15. Now, if at this stage you round a little different than me, your answers will also be a little different than me, and that's fine. So we have all three things we need to rule. To get to 5.72, we added 3 and 2.72 as a series. Therefore, they are a series. What is equal in all parts of a series? Current is equal in all parts of a series. So I'm literally copying the current and stealing it and dropping it. Now I need to calculate the voltage. V equals IR. So 2.72 times 3.15. I get over here 8.57. 8.57 to fill in. I can also come down here and fill in here. And then 3 times 3.15. And I got 9.45. 9.45. Now, because of rounding, that doesn't come out perfectly to 18, but it's pretty close. Again, it's because of rounding. All right, A is all done. Now, specifically, we're trying to find F and G. We're trying to find specifically, let me mark them, this answer and this answer, this answer and this answer. But I think it's a good exercise for us to do all of it instead of only doing those. So let's begin working through the EFG portion. So B through G is a great big parallel of the blue and the red. There's something that's equal in all parts of a parallel. Voltage is equal in all parts of a parallel. Text, please. There we go. Voltage is equal in all parts of a parallel. Now we got to calculate. I equals V over R. 8.57 divided by 5. 1.71. And then I'll come down and do this one. 8.75 divided by 6. 1.43. Okay. So now we've gotten past thinking about the big parallel. Now we can think about what is EFG. EFG, the red branch, is a series of EF and G. So EF and G are a series. EF and G have the same current. So same current for EF, same current for G. Okay. So now we can calculate voltages. V equals IR. 3 times 1.71. I've got 5.13 here. And down here, 1.71 times 2. 3.42. Again, these two come out pretty close to this. Again, because of rounding. Okay, so G is all done. Now we can talk about E and F. EF is a parallel. In parallel, voltage is equal in all parts of a parallel. So E and F get the same voltage. Now we come back this way with Ohm's law. I equals V over R. 5.13 divided by 4. 5.13 divided by 4. And I get 1.28 here. And then 5.13 divided by 12. I get 0.43 when you round here. Those add up. So that's good. So the red branch has now all been done, and that answers the questions from the book. But for practice, let's do the top branch as well. BCD is a series of CD and B. In a series, current is equal. So current is the same, current is the same. Let's calculate voltages. V equals IR, so 1.43 times 3 down here for B. And I've got 4.29 here. Then I'll come up and do this one. 1.43 times 3. Oh, it's the exact same. So 4.29. 4.29. But still, that's because of calculation, not because of copies. And then lastly, we got to talk about CD. CD is a parallel. Therefore, CD has the same voltage as C and D. And then we come back and calculate. I equals V over R. 4.29 divided by 6 comes out to 0.72. And then calculate again. And again, same calculation, so it comes out. So you weren't asked to do all of this stuff. So think about that when you're working through. It'll trim down what you have to do on the test. I hope that's helpful.